The unknown function usually represents a physical quantity. It represents a physical quantity and its derivative represents rate of change. Its derivative represents rate of change. Differential equations are used to describe various phenomena such as motion, growth, decay, and much more in physics, engineering, biology, and economics. Okay, the order of differential equation is the highest derivative of the unknown functions that appears in the equation, such as if the given polynomial is y, then the differential equation, when you differentiate one time dy by dx, okay, then you differentiate another time d square y by dx square, when you differentiate three times d cube y by dx cube, so it has the order 3, it has the order 2, and it has the order 1. The degree of differential equation is power or exponent of highest order derivative, provided the equation is polynomial in derivative, such as dy by dx whole cube. So here 3 is degree, 3 is called the degree here. Now I'll give you one more example here. Dy by dx whole power 5 plus d square y by dx square whole power 3. So here we have to represent the order is 2 and the degree is 3. Why? Because the power or exponent of higher order derivative. So here higher order, this is the order 1, this is the order 2. Higher order derivative power only we have to represent. Okay, now here some of the examples of order and degree of differential equations. Okay, now here what is this dy by dx is it is the one order, and what is the degree here? Degree is also 1 here. Dy by dx here also one order, and what is the degree here? 2 is the degree of this differential equation. Here d square y by dx square is there. So what is the order here? Order is 2, and what is the degree for this order is 1. Okay, now I'll give you one more example. 1 plus dy by dx whole square whole power 3 by 2 is equals to d square y by dx square. Okay, now we have the power should not come in the root form. Okay, that power should come in the integer form, so we have to do squaring on both sides. Okay, now 1 plus dy by dx whole square whole cube is equals to d square y by dx square whole square. Okay, now here what is the order? Order is 2, and what is the degree? Degree here is 2. So I have taken order is 2 and degree is 2. Okay, now d square y by dx square, this is d cube y by dx cube. Here what is the order? Order is 3 and power is 2. Okay, degree is 2. So here in these are the examples. Okay, now another sin dy by dx is equals to d square y by dx square. Here we have this should be in the polynomial form. We have order. Okay, order is 2 here. We have the order 2. We can determine the order, but this is not a polynomial. It is a non-polynomial term. So we cannot define the degree of this polynomial. Okay, now ordinary differential equation. Ordinary differential equation is one in which all the differentials involved have reference to a single independent variable. Okay, consider the example y is equals to mx, where the value of m is called arbitrary constant. Arbitrary constant, where the value of m is called arbitrary constant. Differentiate with respect to x gives the value dy by dx is equals to m. Okay, from 1 and 2 we get y is equals to x. In the place of m put the value dy by dx, which is the required differential equation. If the given relation contains only one arbitrary constant, here you have one arbitrary constant, we have to differentiate one time and eliminate the arbitrary constant. We have to eliminate the arbitrary constant. The order of differential equation is 1. if the given differential, if the given relation contains two arbitrary constant, okay, if you contain a and b, two arbitrary constant, we have to differentiate two times, okay, and eliminate the arbitrary constants, okay. The order of differential equation is a 2. Here what is the order of differential equation? 2. Example, this is one of the example problem. We have form the differential equation from y is equals to a cos x plus alpha, where capital A and alpha are arbitrary constant. Given y is equals to a cos x plus alpha, differentiate the given equation with respect to x, gives the value dy by dx. What is the differentiation of cos x? Minus sin x plus alpha. We have x plus alpha, so minus a sin x plus alpha. Again differentiate the given equation with respect to x, gives the value d square y by dx square is equals to minus a, what is the value of sin x plus alpha, gives the value cos x plus alpha. Okay, substitute 1 in 3. We have d square y by dx square. This is the value of y, so put y here, so minus y. Okay, d square y by dx square plus y is equals to 0. The required differential equation is we have. Okay, now exact differential equation. In this exact differential equation, we have the differential equation will be in this form: m dx plus n dy is equals to 0, where m and n are continuous functions of x and y. The equation is said to be exact if there exists a function phi of x comma y such as dou phi by dou y is equals to m, dou phi by dou x is equals to n. Okay, now phi of x comma y means the equation will be in this form. Okay, this value is m and 2xy, this value is n. Okay, now differentiate with respect to y, gives the value 2y is equals to m dou m by dou y, and 2y is equals to dou n by dou x. When differentiate with respect to x gives the value, so these two values are equal, so dou m by dou y is equals to dou n by dou x. So this is called the exact differential equation. Okay, now steps to solve exact differential equation. Check for the exactness. So here what I have given you the example here, dou m by dou y is equals to dou n by dou x we have found. Then we have to integrate the value of m, putting y as constant, and then we have to integrate the value of n term free from x. The terms of n should be free from x. Then add these two. This is the exact solution of the differential equation which has been formed. Okay, now for you to clearly understand, there are only 3 steps to find the solution of exact differential equation. The equation will be in this form: m dx plus n dy is equals to 0, dou m by dou y is equals to dou n by dou x. We have to first check this: dou m by dou y is equals to dou n by dou x. Then we have to prove integral m dx plus n dy is equals to c. Here y term is constant and here terms should be free from x. Okay, I'll give you one example problem so that you can understand it clearly. Yeah, this is the example problem. Here example, 2x square plus 6xy minus y square dx plus 3x square minus 2xy plus y square dy is equals to 0. Given equation is in the form of m dx plus n dy is equals to 0. Here the value of m is 2x square plus 6xy minus y square, and the value of n is 3x square minus 2xy plus y square. We have to check dou m by dou y, dou n by dou x. Okay, both are equal, so dou m by dou y is equals to dou n by dou x. The given equation is exact. Okay, the solution is integral m dx, putting y term as constant, n dy putting terms free from x is equals to c. Okay, integrate it, gives the value integral 2x square plus 6xy minus y square, and here term should be free from x, means this value becomes 0 and this value becomes 0. We have to integrate only y square. Okay, now to x square, integration of x square gives the value x cube by 3, integration of 6y x square by 2, integration of constant term x, and y square is y cube by 3 is equals to c. Okay, now Yeah, take here the LCM, and this is the required solution which has been formed. You can put 6C or C, okay, nothing will happen. Okay, this is the exact differential equation which has been formed here. Now in some cases the equation no one be exact, means dou m by dou y is not equals to dou n by dou x. Okay, in some cases dou m by dou y will not be equals to dou n by dou z. It is called non-exact. Okay, now we have to multiply something we have to multiply something to get this equation exact. Dou m by dou y is equals to dou n by dou x. This something we have to multiply, this is called integrating factor. Just something we have to multiply, that is called integrating factor. Okay, now then it becomes exact differential equation. Okay, now that is the concept of integrating factor. If the differential equation multiplied by a factor becomes exact, the factor is called integrating factor. Sum of the frequent occurring integrable combination is given by y dx plus x dy is equals to d of xy, y dx minus x dy by y square is equals to d of x by y, x dy minus y dx by x square is equals to d of y by x, x dy minus y dx by xy is equals to d of log y by x, x dy minus y dx by x square plus y square is equals to d of tan inverse y by x. Okay, now okay, equation reducible to exact equation form. There are 5 rules so that you can understand it clearly. If the given differential equation m dx plus n dy is equals to 0 is non-exact, it is non-exact. It can be made exact by multiplying it by a suitable integrating factor. Okay, now if m and n are homogeneous functions of the same order and m dx plus n dy is not equal to 0, then 1 by mx plus ny is an integrating factor of m dx plus n dy, m ds and plus m dy. Now this is the second rule. Okay, if you want you can check here, or else I'll give you this separately, the rule and the steps and one example problem. Okay, if you want you can take the screenshot from this, or else I'll tell you like this. Okay, let us solve some problems using this rule. Okay, this is the first rule. Again I am writing the rule here. If m and n are homogeneous functions of the same order and m dx plus n dy is not equal to 0, then 1 by mx plus ny is an integrating factor of m dx plus n dy. So here what is the differential equation? M dx plus n dy is not equal to 0. Yeah, okay, 1 by mx plus ny, we have to multiply this integrating factor and find the solution. Okay, now putting y term constant. Okay, now this is the example problem. Let us solve this example problem so that you can understand it clearly. Solve x square y dx minus x cube plus y cube dy is equals to 0. So solution is here m x square y and x cube plus y cube. Okay, dou m by dou y is equals to x square, dou m by dou x is equals to 3x square. So here these two values are not equal, so it is not exact equation. To make it exact, we have to multiply by integrating factors such as m and n are homogeneous functions of same degree. The integrating factor is 1 by mx plus ny. So 1 by mx plus ny is equals to 1 by x cube y minus x cube y minus y power 4. So this value gets cancelled out, minus 1 by y power 4. Multiply the given equation by minus 1 by y power 4. Gives the value x square by y cube dx plus x cube plus y cube by y power 4 dy. Now exact solution. Okay, means x square by y cube dx plus x square plus y square by y power 4. This value gives it x cube by y power 4 plus y cube by y power 4. So this value gets cancelled out, and here we have to take the term free from x. So we have to take here this 1 by y plus x cube by y power 4. Okay, we have to take only this value, we should not take this value because the term should be free from x. So we are not taking this value. Okay, integrating 1 by y dy is equals to c. Okay, Now x cube by 3 y cube plus log y is equals to c. Okay, log y is equals to x cube by 3 y cube plus c. This is the required general solution which has been formed here. Now this is rule 2. If m dx plus n dy is equals to 0 is of the form y into f1 of xy plus x into f2 of xy is equals to 0 and mx minus ny is not equal to 0. If this value is not equal to 0, then 1 by mx minus ny is an integrating factor of m dx plus n dy. So these are the steps which has been given. The given equation is in this form: y into f1 xy plus x f2 xy. Then we have to check mx minus ny is not equal to 0. Then we have to multiply 1 by mx minus ny. Then find the solution of this equation. Okay, this is the example problem we have to discuss. Solve xy sin xy plus cos xy into y dx plus xy sin xy minus cos xy into x dy is equals to 0. Here the value of m is this value and n is this value. So the equation is of the form y into f1 of xy plus x into f2 of xy. Okay, now the integrating factor is 1 by mx minus ny. So we get the value like this. When you multiply xy sin xy means this xy gets cancelled out. Cos xy sin xy means tan xy, and this value is here. Okay, this value will be here, plus cos xy gets cancelled out. This y and this y gets cancelled out. This is 1 by x. Okay, plus this xy xy gets cancelled out. Sin xy cos xy gives the value tan xy, and this x value remains here, and this is cos xy gets cancelled out. X gets cancelled out. Minus 1 by y dy is equals to 0. This is the exact differential equation which has been formed. Required solution is integral m dx plus n dy is equals to c. Okay, this is the value we have to find out. M dx y tan xy plus 1 by x gives the value y 1 by y log secant xy. This y gets cancelled out, plus 1 by x integration log x means log secant xy plus log s. This is the value of m. Now integral n dy is equals to minus 1 by y dy, that is equals to minus log y. The required solution log of secant xy plus log x. This is the value of log y only. Okay, minus 1 by y, this is the value minus log y. So log, add this to this and this, when you add gives the value log secant xy plus log x minus log y is equals to log c, or else x by y is equals to into secant xy is equals to c, which is the required solution of this differential equation. Rule 3. For the equation m dx plus n dy is equals to 0 if dou m by dou y minus dou n by dou x by n is a function of x only. Say f of x, then integrating factor integral e power f of x dx is an integrating factor. So these are the steps which has been involved. M dx plus n dy is equals to 0. This is the given step, and dou m by dou y minus dou n by dou x by n, we have to check it out. Then here integrating factor is this e power integral f of x dx. Okay, this is the integrating factor we have. Then find the solution. Solve y dx minus x dy plus 1 plus x square dx plus x square dy sin y dy is equals to 0. Okay, solution is we have to take the dx terms. We have to take the dx terms, here dx term, here also dx term common. Okay, dy term we have to take it common. So what is the value of m? M is equals to y plus 1 plus x square, n value is x square sin y minus x. Okay, dou m by dou y is equals to 1, dou n by dou x is equals to 2x sin y minus 1. dou m by dou y is not equals to dou n by dou x. The equation is not exact. So what we have to do, we have to multiply this value. This value becomes 2 into 1 minus x sin y minus x 1 minus x sin y. Okay, when you cancel this out, this value gives minus 2 by x is equals to f of x. Integrating factor here is e power integral f of x dx. So what you'll get, e power integral minus 2x by x dx. Okay, minus 2 log x e power log 1 by x square. Okay, e and log gets cancelled out. What is this value? 1 by x square. Multiplying the equation by 1 by x square. So what the value here becomes, y plus 1 by x square gives the value y by x square 1 by x square plus 1, and x square sin y means x square gets cancelled out. So what the value becomes, sin y, and minus x, what this value, minus x by x square, this value becomes like this. Okay, but we have to not take the term should be free from x. So when this value becomes 1 by x, this value when integrating, this value becomes 0 here. Okay, now this value is 0, so we should take only sin y value. So y by x square becomes the value minus y by x, 1 by x square becomes the value minus 1 by x plus x, and what is the integration of sin y, minus cos y is equals to c. This is the required general solution which has been formed here. Now for the equation m dx plus n dy is equals to 0. Okay, this is the equation which has been formed if dou n by dou x minus dou m by dou y by m is the function of y only. Then say g of y, then e power g of y dy is an integrating factor. So these are the steps which has been involved. M dx plus n dy is equals to 0. Dou n by dou x minus dou m by dou y by m. Okay, we have to check this out. Now this is the integrating factor e power g of y dy, and this is the required solution which has been formed here. So now this is the question which has been given here. Solve 3x square y power 4 plus 2xy dx plus 2x cube y cube minus x square dy is equals to 0. So this is the value of m and this is the value of n. So dou m by dou y is equals to 12x square y cube plus 2x, dou n by dou x 6x square y cube minus 2x. So dou m by dou y is not equals to dou n by dou x. The equation is non-exact. Okay, now when you calculate this value becomes, take this common, and this value becomes minus 2 by y minus 2 by 5. When you integrate this, e power minus integral 2 by y dy is equals to, this value becomes e power minus 2 log y. Okay, then when you take e power log 1 by y square, e and log gets cancelled out and the value becomes 1 by y square. Okay, now Now 3x square y power 4 plus 2xy by y square dx plus 2x cube y cube minus x square by y square dy is equals to 0. So what this value becomes here, when you divide this value separately, 3x square y square plus 2x by y, 2x cube y by y square gets cancelled out, minus x square y dy is equals to 0. Okay, now when you taking the solution for this equation, here y term is constant, so 3x cube, what is the integration of x square, x cube by 3, I'll take. Okay, we have to multiply taking y terms and constant, and here we have to take x term free from x term, so this value becomes 0, this value becomes 0, so n value is not there, and this value is 3x square y square plus 2x by y. So what is the integration of 3 x square into x cube by 3, so this gets cancelled out, plus 2 into x square by 2, 2 by y into, okay, this value cancelled out, x square by y, x square by y, x cube y square. Okay, this is the required solution which has been formed here. If the equation m dx plus n dy is equals to 0 is of the form, is of this form, then a b c d all are constant, h power k and x power h plus y into y power k, this is the integrating factor of h comma k, are so chosen that after multiplying this value becomes exact here. Okay, Now m dx plus n dy is the equation. This equation m dx plus n dy, this equation will be in the form of this. Okay, when you multiply this factor, this is the integrating factor, this becomes exact. Okay, then we have to find the solution here. Okay, this is the question. xy into y dx plus x dy plus x square y square into 2y dx minus x dy is equals to 0. Okay, comparing the equation with this form. Okay, this is the equation which is the, we have to compare this equation with this form. Okay, where a value is 1, b value is 1, c value is 2, d value is 2. Okay, m value is 1, n value is 1, p value is 2, q value is minus 1. Let x power h y power k be the integrating factor. So multiply the equation by integrating factor x power h y power k. Okay, here we have the value of x power 1 y power 1. So x power h plus 1 y power k plus 1 y dx plus x dy, I am putting here common, and x power 2 plus h y power 2 plus k, 2y dx minus x dy is equals to 0. Okay, now multiply this separately. So what this value become? X power h plus 1 y power k plus 2 dx plus x power h plus 2 y power k plus 1 dy plus x power 2 plus h y power 3 plus k into 2, this 2 value I am writing here, dx minus x power 3 plus k y power k plus 2 dy is equals to 0. So now take dx in one step, dy terms in another step, common. Okay, now take dx common here, so this value becomes like this and dy value will become like this. Okay, this is the equation of m dx plus n dy. Now for this to become exact, so what we have to do, we have to differentiate this equation. To become exact, we have to differentiate these equations. So after differentiating, taking the value of k plus 2 x plus, taking the value of x plus h value, x plus h k y power k plus 1 value common, so gives the value k plus 2 h plus 2 and x plus h plus 2 k plus 2 h plus 2 k plus 2, this term common, gives the value 2k plus 6, 2k plus 6 is equals to minus h minus 3. Okay, when you do this, gives the value h minus k is equals to 0. When you solve this, gives the value h plus 2k is equals to minus 9. When you solve these two, gives the value h minus k is equals to minus 3. Integrating factor is h power minus 3 y power minus 3, that is equals to 1 by x power 3 y power 3. Okay, multiply the equation by 1 by x cube by cube, that is we get xy y dx plus x dy by x cube y cube plus x square y square x cube y cube 2y dx minus x dy is equals to 0. Okay, now when you multiply it, gives the value here 1 by x square dx plus 1 by xy dy plus 2 by x dx minus 1 by y dy is equals to 0. Taking dx terms common, 1 by x square y plus 2 by x dx, 1 by xy square minus 1 by y dy is equals to 0. So this is the value of m, this is the value of n. Okay, we have to take this value 0, so we have to take minus y, minus 1 by y value, so this value is 0 because we have to take term free from x here. Okay, now here putting y term as constant, putting y terms as constant, so what this value becomes, minus 1 by x, integrate, gives the value minus 1 by x plus 2 log x minus log y is equals to c. So this is the required solution which has been formed here. Okay, hence thank you and have a nice day. If you have any doubt in factor linear equation. Hello, let us start with a new topic called integrating factor linear equations. Linear equation is an equation of the form, the given equation will be in the form of dy by dx is plus py is equals to q. Okay, in this form the given equation will be there, where p and q are the functions of x alone, k or constant, is called an linear equation of first order. Okay, the solution, the general solution can be obtained by multiplying the equation both sides by e power integral p dx. Okay, I'll tell you this as an integrating factor. Okay, dy by dx into integrating factor plus py into integrating factor is equals to q into integrating factor. D by dx into y into integrating factor is equals to q into integrating factor. Integrate we get y into integrating factor integral q into integrating factor dx plus c, which is the required equation which has been formed here. Write the given equation in the form of dy by dx plus py is equals to q. Find the integrating factor of e power integral p dx. Okay, now this is the solution which has been formed here. Y into integrating factor integral q into integrating factor plus c. If the given equation is in the form of dx by dy, here dx by dy plus py is equals to q. Sorry, px. Here we have x equals to q. Then the integrating factor will be in the form of e power p dy, and the solution will be x into e power p dy is equals to integral q into e power p dy plus c. The solution will be in this form. Okay, these are the steps which has been involved here. Okay, this is the given equation will be in this form. This is the integrating factor, and this is the finding the solution of this integrating factor for this linear equation. Okay, using integrating factor. Okay, solve cos x dy by dx plus y sin x is equals to 1. Divide the equation by cos x, because to make this as common, dy by dx plus cos x by sin x in by sin x by cos x into y is equals to 1 by cos x, that equals to dy by dx equals to tan x y into y is equals to secant x. This is the form of linear equation dy by dx plus py is equals to q, where the value of p is tan x, q is secant x. Integrated factor e power integral tan x dx gives the value e power log secant x, that equals to secant x. E and log gets cancelled out, secant x. Solution: y into secant x is equals to integral of integrating factor, this is the value of q, dx plus c. So y into secant x integral secant square x dx plus c gives the value y secant x equals to tan x plus c, which is the required solution for this linear equation. Bernoulli's equation. This is another concept from the linear equation. Okay, after linear equation, this equation is of the form of dy by dx plus py is equals to q into y power n, where p and q are the functions of x alone, is known as Bernoulli's equation. It can be reduced to linear form as follows: dy by dx plus py is equals to q y power n. Divide both sides by y power n. We get y power minus n dy by dx plus p into y power minus n plus 1 is equals to q. This equation forms like this. Now consider this value. Now consider this value as v. Then we get minus n plus 1 y power minus n dy by dx. This value becomes dv by dx. So take this common. So what this value becomes? 1 by 1 minus n dv by dx. Substitute this 2 in equation 1, gives the value 1 by 1 minus n dy by dx plus pv is equals to 1 by 1 minus n into q. This is the linear equation. So we have to convert the Bernoulli's equation into linear equation, then we have to find the solution for this. So this value becomes dy by dx plus py is equals to q y power n. So this is the questions of Bernoulli's equation will be there. Then we have to convert it into linear equation. Okay, by multiplying or dividing something. So we convert into linear equation, then find the solution of this linear equation. Okay, this is the example problem, so that you can be clear with the concept of Bernoulli's equation. Okay, given equation is of the form of Bernoulli's form. This equation is of the form of Bernoulli's form. So put tan y. So we have to take this tan y. Tan y is equals to tan y is equals to v. We have to take tan y is equals to v. secant square y dy by dx is equals to dv by dx. So this value becomes dv by dx. Substitute in the given equation, we get x cube dv by dx plus 3x square dv is equals to cos x dv by dx plus 3x square by x cube. So this gets cancelled out. This value becomes 3 by x into v is equals to cos x by x cube. This is the linear equation in V. So what is the value of P? P is equals to 3 by x. Q value is cos x by x cube. Integrating factor e power integral 3 by x dx is equals to e power 3 log x. So this value gives x cube. The solution is given by v into x cube plus integral cos x by x cube into x cube dx plus c. So this x cube gets cancelled out. Integration of cos x is sin x, b into x cube sin x plus c. So what is the what in the place of v we have taken tan y. In the place of v we have taken tan y here. So substitute that value here. Substitute degrees Celsius. Okay, let theta be the temperature at any time t. Okay, at any time t. By Newton's law of cooling, d theta by dt is equals to minus k theta minus phi, where phi is the temperature of air. Okay, now where phi is equals to 20 degrees Celsius. This when phi is equals to 20 degrees Celsius, d theta by dt is equals to minus k theta minus 20. D theta by theta minus 20 is equals to minus k into dt. Cross multiply this value, gives integrating theta is equals to 20 plus c into e power minus kt. When t is equals to 0, that's the starting. Theta will be 80 and c is theta will be 100 and c value is 80. Equation 1 becomes theta is equals to 20 plus 80 into e power minus kt. I am substituting the values here. Okay, I am substituting the values here. So 80 e power minus kt. When t is equals to 10, theta is 75. Okay, now here what is the value of this? 100 is equals to 20 into 80 e power minus kt. This is the value. In the place of theta we have to substitute 100. When t is equals to 10, theta is equals to 75 degrees Celsius. So 75 is equals to 20 plus 8, 20 plus 8 into e power minus k minus 10k. 55 is equals to 80 into e power minus 10k. Here 80 is there. E power minus 10k is equals to 55 by 80. Gives the value 11 by 16 or e power minus k 11 by 16 whole power 1 by 10. When t is equals to 30, to find theta is equals to 20 plus 80 e power minus kt. 20 plus 80, what is the value of t? 30 e power minus 30k. 20 plus 80 e power minus 10k whole cube. Okay, whole cube I'm writing here. Whole cube. Then what this value becomes here? 20 plus 80, 11 by 16 whole cube. So when you cube this and find the value, the theta value will becomes 46 degrees Celsius. When theta is equals to 25 degrees Celsius, to find t, we have to take 25 is equals to 20 plus 80 into e power minus kt. So 25 minus 20 gives the value 5 is equals to 80 e power minus kt. 5 by 80 is equals to e power minus kt. E power minus kt is equals to 1 by 16. E power minus kt is equals to 1 by 16. So this is the value which has been formed. Now we have to take in the place of e power minus kt, 11 by 16 whole power 1 by 10 is equals to 1 by 16. So what is the value of t? T is equals to 10 log 16 by log 16 minus log 11. Okay, now e power minus kt. When you remove e, this value becomes log. Okay, this value becomes log. So 10 log 16 by log 16 minus log 11. Okay, now law of natural growth or decay. Law of natural growth or decay. Okay, if the rate of change of quality y is proportional to the quantity present at any time, then dy by dt is equals to y, dy by dt is equals to k into y. If there is a growth, the k value is positive. If there is a decay, the k value is negative. Okay, if there is a growth, k value is positive. If there is a decay, the k value we have to take it as negative. Okay, now this is an example problem which has been given. A bacterial culture growing exponentially increases from 100 to 400 grams in 10 hours. How much was present after 3 hours? In 10 hours, how much it was present after 3 hours? Means it is growing from 100 to 400 grams in 10 hours. Then how much it will grow for 3 hours? Means dou n by dou t is equals to n. Then dou n by dou t is equals to k into n. Dou cross multiply this, dou n by n is equals to k into dt. Integrating log n is equals to kt plus k1, where k1 is the constant. So n is equals to, when you remove n, this power, this here, e power kt plus k1 exponential form it comes. E power kt is equals to c into e power kt. E power k1 we are taking c here. N is equals to c into e power kt. The equation 1 gives the number n of the bacteria at any time. Equation 1 gives n as the bacteria at any time. Now given t is equals to 0, n is equals to 100 and a is equals to 100. Equation 1 reduces to n is equals to 100 into e power kt. Reduces to 100 into e power kt. Also gives t is equals to 0, n is equals to 400. 10. T is equals to 10, n is equals to 400. From equation 2, 400 is equals to 100 into e power 10k. E power 10k is equals to 4. 10k is equals to log 4. K is equals to 1 by 10 log 4. Okay, equation 2 becomes n is equals to 100 e power log 4 whole power 1 by 4. 100 into 4 whole power t by 10. 100 into 4 whole power t by 10. Okay, when t is equals to 3 hours to find, n is equals to 100 into 4 power 3 by 10. 100 into 4 power 0 0.3. 100 into what is 4 power 0 0.3 gives the value 1.5157. N is equals to 151.57, which is the required solution which has been formed here. Trajectory: two families of curves such that every member of one family cuts each member of another family of curves. A triangle are called orthogonal trajectory. Orthogonal trajectory. Okay, now this is the diagram belongs to, one of the examples of the diagram belongs to orthogonal trajectory. Okay, now application. In electric field, the path along which the current flows are the orthogonal trajectory of the equipotential curve. Okay, in fluid mechanism, the streamline and equipotential lines are orthogonal trajectories. In thermodynamics, the lines of heat flow are perpendicular to isothermal curve. Method of finding orthogonal trajectory. Okay, form the differential equation of given family of curve f of x y c is equals to 0, phi of x y dy by dx is equals to 0. Now we have to calculate this and replace dy by dx by minus dx by dy to get the differential equation of orthogonal trajectory. Okay, phi of x comma y minus dx by dy is equals to 0. Solve this equation to get the equation of orthogonal trajectory here. Okay, these are the 3 steps involved to solve orthogonal trajectories. The given equation will be in the form of f of x y c is equals to 0. Replace dy by dx by minus minus dx by dy. Now x y minus dx by dy is equals to 0. Okay, now This is the example problem that I am giving to you. Find the orthogonal trajectory of the family of semi-curved parabolas ay square is equals to x square, where a is the parameter. Given equation of curve ay square is equals to x square. Given equation of the curve ay square is equals to x square. Sorry, x cube. X cube here. Differentiate with respect to x. 2ay dy by dx is equals to 3x square. Eliminate a from 1 and 2. We get 2 by y dy by dx is equals to 3 by x, because we have to eliminate. This is the arbitrary constant, so we have to eliminate that. Okay, 3 by x, which gives the differential equation of given family of curve replacing dy by dx. This is the differential equation which has been given. Now we have to replace dy by dx by minus dx by dy. We get 2 by y minus dx by dy is equals to 3 by x. Minus 2x dx is equals to 3 by dy. So 2x dx plus 3y dy is equals to 0. So this is the exact differential equation, which is in the form of mdx plus ndy is equals to 0. So this is in the form of exact differential equation. Now we have to find the solution. Integrating mdx plus integrating ndy is equals to c. So 2 into x square by 2 plus 3 into y square by 2 is equals to k1. So this is the solution of the equation which has been taken. Okay, this is the required solution. Okay, in the place of k1 I am putting c is equals to k. This is, I am taking the HCF, 2x square plus 3y square is equals to c. In the place of c, 2k1, which is a family of eclipse. Okay, thank you and have a nice day. If you have any kinds of doubts, please comment me in the comment section. Thank you and have a nice day.